In this next directions in section 2 here, we're supposed to graph each relation. Remember, a relation is a set of ordered pairs or equation, and find the domain and range. Then determine whether the relation or equation is a function. Okay, and we're going to look at number 14 right here. We have y equals negative 2x plus 1. Okay, if you kind of recognize and remember some things from math, that is a linear equation. In other words, the graph's going to be a line. But you can make a table if you wanted to. You could make a table and go through that process. And that's what I would do for some of the stuff that is not linear, that's not like in slope-intercept form or standard form. Make a table. So like when you get to 16, when you have number 5 or 15, which is x squared, which is quadratic, I would make a table. Plug in some values and kind of think about those things in the graphs you talked about in the past. This one, I noticed that it's y equals negative 2x plus 1. That's in slope-intercept form. That's in y equals mx plus b form. Okay, so if you remember your slope-intercept method of graphing, okay, and I'm going to make this grid a little bit bigger here. We are going to graph the y-intercept, which is positive 1. So we're going to be right there at positive 1. And then if you notice, the slope is negative 2 over 1. So we're going to go down 2, right 1. So I'm going to be right there. If I continue that, I'd go down 2, right 1. I'd be right there. If I went the other way, I'd be up 2, left 1. And you are going to draw your line. And I'm going to make this a little bit bigger here. And we're going to draw our line. I didn't get that real great there, but you know what I mean. You're going to connect that point. It's a line. Okay, now let's shrink it back down, and we need to look at the domain and range. Remember, domain is what x can be, and you did some of this in Intermediate Algebra 1. If you notice, this is a line that does go, if you think about domain, domain is the x. So in other words, if we're thinking about this x-axis here and these x values, this end of the graph down here does go infinitely out that way. It keeps going down and out. This end of the graph up here, or this line, does keep going up, but it also keeps going that way. So if you think about, if I went to any point on that x-axis, think about the domain, I could go to any fraction, integer, whatever it is, and the domain is what we call all real numbers. Now you can either write out all real numbers, you can use our little symbol that we have for all reals, which is kind of that double barred R, all real numbers. Okay, and I'll put the numbers up here. Either one of those is okay, but that's all reals. Now, the range is what y can be. So if you think about, this does go infinitely down this line. So as I go infinitely down, I can go to all these y values. It does go infinitely up. Okay, so I could go to anything and get to that line. That also is all real numbers. Okay, and anything that's linear, unless it's a horizontal or vertical, both the domain and range are going to be all real numbers. Now, is it a function? Does it pass the vertical line test? Yes, everywhere we drew a vertical line would only go through there once. So that's yes. Okay, so now let's go over to our next page. Okay, and we are going to go to number 22. So we're going to go to this one right here. And we'll use the graph. Now there's given a graph, determine the domain and range. I'm going to make this a little bit bigger. Okay, this is a linear function. If you notice, that's in standard form, ax plus by equals c. You talk a little bit about that in intermediate algebra, and we'll talk more about that in this class. Now, this does have arrows on the end, and so it will go on forever in each direction. Okay, so the domain is all reals. So what x can be, I go to any x value, I get to the line. It does go infinitely up and down. This line keeps going up and keeps going down. So that is also all real numbers.